Question 348 in Munson is about a water jet cutter nozzle. So this is a nozzle that's spraying down onto whatever the workpiece is that it's cutting. And for a water jet cutter to work, it has to operate at really high velocities. In this case, we're told 700 meters per second. Very narrow jet of water, 0.1 millimeters wide, so 100 microns, very narrow, going at 700 meters per second. If we neglect friction, what pressure is required back up here in the nozzle in order to get this velocity of 700 meters per second out here in the jet? To get the answer, we apply Bernoulli's equation. We need to pick 2 points. I'll call that point 1 and this point 2. They're along a streamline following out through the nozzle. And we have Z1 plus P1 over rho g plus V1 squared over 2g equal to Z2 plus P2 over rho g plus V2 squared over 2g. Now, if we say that the elevation is not really very important in this, there is some obvious difference in height here, but it's going to be small compared to the effects of the pressure increasing the velocity enormously. And the pressure at location 2 is atmospheric, so we're interested in how much bigger is the pressure at 1 than atmospheric pressure. The velocity at 1, much less than 700 meters per second. So we'll ignore that term, and we wind up with just the pressure has to be big enough to produce this velocity. We can cancel out g on both sides, and we wind up with P1 equal to rho V2 squared over 2. And if it's water with a density of 998 kilograms per cubic meter, and the velocity that we want is 700 meters per second coming out, and that has to be squared to get V2 squared, and then divide the whole thing by 2, we wind up with 998 times 700 squared divided by 2 is a very big number, 2.445 times 10 to the 8th pascals. Now let's try to put that into context of numbers that we understand. 1 bar, 1 atmosphere roughly, is 100,000 pascals or 100 kilopascals. So that will be, or 10 to the 5 pascals. So that'll be 2,445 times 10 to the 5, or 2,445 bar. That's still a very high pressure. The question also asks, what's the flow rate? So we're interested in the volume flow rate Q, which will be the velocity times the area. 700 meters per second times pi times the diameter squared, 0.1 times 10 to the minus 3 squared over 4. That'll be 0.1 is still 5.5 times 10 to the minus 6 cubic meters per second. That's a very small number. Whoops, 5.5 times 10 to the minus 6 cubic meters per second. Now a cubic meter is 100 centimeters by 100 centimeters by 100 centimeters, or so that's 5.5 cubic centimeters per second, or milliliters per second.